Science to me means curiosity. Science to me means questioning why things happen the way they happen. We need to understand why things happen from fundamental perspective. My name is Innocent Ezenwa and I'm a postdoctoral fellow at Carnegie Institution for Science. I'm a mineral physicist, and as a mineral physicist, I use physics and chemistry principles to understand the dynamics that goes on in the interior of the terrestrial planets. So what I mean by the terrestrial planets, I mean the Earth, the Mercury, Mars, Venus. So the interior of these planets are divided into sections. You have the core, you have the mantle, and you have the crust. So my research is mainly in the core. The motion of iron material, which is largely the composition of the core, is what produces the magnetic field in our own planet Earth. So with this geomagnetic field, that's the reason why we are alive on Earth, because without the magnetic field, the sun radiation will strike us and there will be no living object on the surface of the Earth. So it's important to understand all these phenomena, because without our deep understanding of them, then we might not be able to do some space exploration or understand why we are here on Earth and what could exist beyond the Earth. I've always loved physics all the way from high school. I was one of the best physics students in my high school, and I studied physics and astronomy at the University of Nigeria. I never thought I would go in the direction of becoming a mineral physicist. My parents wanted me to become a medical doctor. And then for some reason, I found myself in physics department and I loved it. As a mineral physicist, I measure the transport properties of iron at pressure and temperature conditions. So when you go into the deep interior, the pressure and the temperature is increasing. And we replicate that condition in the laboratory. And to do that, we use what we call here the high pressure cubes. And if you put this in a press, we recreate the pressure and then we heat up our sample to reach a target pressure, and we could do all kinds of cool experiments, measure the electrical transport properties, measure thermal transport properties, measure viscosity, and all other properties. With that, we kind of give the information to the modelers, and they will use our information to model and recreate the geomagnetic field in order to understand the phenomena that we don't really know much about. Science has to do a whole lot with how you imagine things. So doing science in West is not as difficult as doing science back home in Nigeria. Back home with textbooks, you imagine a whole lot, and that for the fact that you have to imagine a whole lot without having those resources, you build your resilience. You build yourself so tough that when you have those resources, you have a kind of potentials in you that would catapult you as a person. So here, science is cool because you have access to a whole lot of things. And that's what I love about doing science here in DC, in Canada, in Japan, where I was before coming here, and beyond. The most challenging thing about my work is the experiment itself. You're doing something new. There's a whole lot of potentials that something could go wrong. We take precautions, but sometimes we could have a blowout. You have a bang, which could be terrifying. And when you have a blowout, your experiment is lost, and there's frustration that comes with it because you don't have results, and the day is completely gone, and you have to cope with you have to get data to present and all that. So there's a whole lot of pressure that comes with it. The coolest thing about my work is the people I work with. Everyone I work with here, they are friendly. They all put up smiling faces, and when you come in the morning, you have to be in the right spirit to do science. So, and the people that surround you matters a lot. You have to have passion for what you do. I have passion for it. I think I'm born to do science.